Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. Today we are going to explore about numbers. What are numbers? I have some pens in my hand. I have to count these pens. How do I start counting? 1, 2, 3 and 4. Did I start 0, 1, 2? No, isn't it? Why? We don't use 0 for counting numbers. So the numbers used for counting are 1, 2, 3, 4, so on. The numbers used for counting are called as counting numbers or natural numbers. The set of natural numbers is represented by the letter n. All the natural numbers, including 0, is called as the set of whole numbers. So the set of whole numbers consists of 0, 1, 2, 3, so on. The set of whole numbers is represented by the letter W. All the natural numbers, 0 and all the negative numbers put together is called as the set of integers. So the set of integers consists of minus 1, minus 2, minus 3, so on, as well as 0 and all the positive numbers like 1, 2, 3, so on. The set of integers is represented by the letter Z. Are only these numbers in the universe? Don't we have any more numbers in the universe? We do have. What about fractions, decimals, squares, square roots, cubes, cube roots, so on. So which set do all these numbers belong to? We have another set of numbers called as rational numbers. Let us get into the details of this set of rational numbers. As we have discussed earlier, the numbers used for counting objects are called as counting numbers or natural numbers. The set of natural numbers is denoted by the letter n and the elements of this set are 1, 2, 3, so on. If at all this set of natural numbers or counting numbers includes the number 0 in it, this set is called as whole numbers and it is represented by the letter W. Now, all the positive numbers including 0 and all the negative numbers put together is going to be called as the set of integers and is represented by the letter Z. If we observe, natural numbers is contained in the set of whole numbers and the whole numbers is contained in the set of integers, or the other way we can write as natural numbers is a subset of W, that is the whole numbers, which is in turn a subset of integers. Now, are the numbers, natural numbers, whole numbers and integers, are these the only numbers in the universe? No, we have fractions, decimals, square roots, cube roots, so on and so forth. Where do these numbers belong to? Which set do they belong to? There is a specific set called as rational numbers. What are rational numbers? What are the elements belonging to the set of rational numbers? And let's go into the details. The set of rational numbers is represented by the letter Q. For any number to belong to the set of rational numbers, it has to follow 3 conditions. What are those conditions? An element belongs to the set of rational numbers if it can be written in the form of a fraction. If it is in the form of P by Q, where P comma Q are integers. That means both the numerator and denominator should be integers, and mind you, both the fraction should be in its lowest terms. It should be in its lowest terms. Both the numerator and denominator should be integers, and the very important condition, the denominator should never be equal to 0. Such numbers belong to the set of rational numbers. Now let us check. Does 2 belong to the set of rational numbers? Does it follow all these conditions? The first condition, it should be written in the form of a fraction. Is 2 in the form of a fraction? As such, no. But if at all I write 2 as 2 by 1, it is in the form of a fraction. So the first condition is satisfied. Do both the numerator and denominator belong to the set of integers? Yes. 2 and 1 both are integers. So the second condition is also satisfied. What about the last and very important condition? Denominator should never be equal to 0. Here the denominator is 1. Is it equal to 0? Never. 1 is never equal to 0. Therefore, the third condition is also satisfied. Hence, we know that 2 belongs to the set of rational numbers. In that case, don't you think that all the natural numbers, for that matter all the whole numbers and integers, belong to Q? Let us check it in detail. How about minus 5? It is an integer. We are sure that it is an integer. Does it belong to the set of rational numbers? Let us consider all the three conditions. The first condition is it should be written in the form of a fraction. Can I write minus 5 in the form of a fraction? Yes, of course. Minus 5 can be written as minus 5 by 1. So the first condition is satisfied. Second condition, both the numerator and denominator should be integers. Here, minus 5 is the numerator, 1 is the denominator, both are integers. Therefore, the second condition is satisfied. Third condition is also satisfied because 1 is never equal to 0. Therefore, we have proved that all integers belong to rational numbers. So, natural numbers is a subset of whole numbers, which is a subset of integers, which in turn is a subset of rational numbers. If at all, this is a set of all the numbers in the universe, this is a set of all the numbers in the universe, then I consider this as a set of rational numbers. As we have already observed, rational numbers consist of integers inside it, or Z is a subset of Q. Integers is a subset of rational numbers. The reason is every integer is a rational number and integers consist of whole numbers. Whole numbers in turn consist of natural numbers. So we can observe it clearly that natural numbers is a subset of whole numbers, which is a subset of integers, and that is a subset of rational numbers. So how do you represent the set of rational numbers using roster form or set builder form? Can we represent each and every rational number? No. So what is the procedure to represent rational numbers? We have a set builder form, which gives you the condition Q or rational numbers is equal to X such that X is in the form of a fraction where both P and Q belong to Z and Q is never equal to 0. This is a set representation form of rational numbers. Thank you. So friends, that was the video based on Introduction to Rational Numbers. Let's continue in the next video. Thank you.